So, thank you very much for joining us for this workshop on the methodologies for the use of history and philosophy. I'm really glad that Maria Martinez Ordaz and Teresa Rodriguez continue their collaboration on this topic. And yes, once more, I'm really glad that all of you are here for this wonderful workshop. So we are a bit late, so I will keep this very short. Actually, I almost finished. Yeah, and enjoy the this workshop. I'm sure that it will be really fruitful. And yeah, thank you once more, Teresa and Maria.
Thank you, Luis. Well, welcome to this workshop. First of all, I would like to thank the Institute for Philosophical Research for its support, especially our director, Luis Estrada, for being here with us, and also Beth Sarmiento and Alfonso Coronel for their support in the streaming. And as Luis was saying, Maria and I began planning this event in 2019 for the year 2020, but the pandemic came and the project had been suspended until now. So we are very pleased to have you here. And as you can see in this workshop, we will address a wide range of topics. I'm not going to go through them now, but all these discussions aims to foster a deeper understanding of how historical inquiry can inform philosophical analysis across diverse tradition and contexts. So thank you very much for participating in this workshop. Thank you very much for Kirsten, to Kirsten for being our keynote speaker today. And well, I think we can move to our first talk. I will make a very brief presentation. Kirsten Walsh is a senior lecturer in the Department of Social and Political Sciences, Philosophy and Anthropology at the University of Exeter in the UK. She completed her PhD in 2015 at the University of Otago in New Zealand, focusing on the scientific methodology of Isaac Newton. Before moving to Exeter, she spent 2 years as an assistant professor in the philosophy department at the University of Nottingham. And her research focuses on early modern science, using the methods of integrated history of philosophy of science and philosophy of science in practice to study the work of Isaac Newton and the early Royal Society. The title of her talk is Newton's Metaphysics in Practice. And Kirsten, we're very honored to have you here, and the floor is yours. Thank you very much.
Thank you for inviting me. Oh, I'm not able to share my screen.
Yeah, we're going to solve that right now.
Great.
Wait just a second.
Yes, el permiso ya está.
Oh, thank you.
It's okay.
Great, it's there. How's that? That seems to be working. Can I just check?
Yes.
Can I just confirm how long do I have to speak? Is it 1 hour?
Yes, 1 hour, yes.
Great. Okay, thanks very much. I guess one of the nice things about being the first speaker of the conference is that I get to be the first person to thank the organizers, Teresa and Maria, for running this workshop, which, I mean, you know, we don't know yet, but judging by the lineup of speakers, it looks like it's going to be really, really wonderful. And also thank you so much for inviting me. I'm really delighted to share my research with you. Okay, I'll just jump straight in. Okay, so Isaac Newton was explicitly and infamously anti-hypotheses. So for Newton, a hypothesis is a speculative conjecture. It's a proposition that postulates unmeasurable or unobservable entities, causes, or processes. So, and yet, right, and so we see this kind of this shown in a lot of different passages in Newton's work. So this passage comes from his Optics, where he says this analysis consists in making experiments and observations and in drawing general conclusions from them by induction and admitting of no objections against the conclusions, but such as are taken from experiments or other certain truths, for hypotheses are not to be regarded in experimental philosophy. And there's this passage from the General Scholium at the end of the Principia, where Newton says, I have not as yet been able to deduce from phenomena the reason for these properties of gravity, and I do not feign hypotheses. That's the famous hypothesis non fingo line. And he goes on, for whatever is not deduced from the phenomena must be called a hypothesis. And hypotheses, whether metaphysical or physical or based on occult qualities or mechanical, have no place in experimental philosophy. Okay, so, he's very clearly telling us here that that speculation of any sort has no place in experimental philosophy. His expressed attitude, though, towards hypotheses often seems to be at odds with this. With other aspects of his work. And so, for example, in the Optics and in the Principia, the very same text in which he makes these methodological claims against using hypotheses, we find explicitly labeled hypotheses being used in his work. And in addition to this, both of these works contain kind of extended speculative metaphysical discussions. In the General Scholium, in the Principia, we find these in the General Scholium, as well as things like the Scholium on space and time at the beginning of the book, and in the Optics, we find this in the Queries at the end. Also, going beyond his published work, we find Newton kind of engaging in metaphysical discussions in his notes and manuscripts. So this famous text is called De Gravitatione, after the opening words of the manuscript. And here Newton famously does a lot of metaphysics. And of course, we also find this in some of his alchemical texts. This one's of nature's laws and processes in vegetation, where we find again lots of speculative metaphysics. So while Newton rails against hypotheses and speculative metaphysics, they seem to find their way into much of his written work. And so Newton's commentators seem to face a dilemma. Either they need to take Newton's metaphysical speculation seriously and downplay the sincerity of his methodological claims, or they should take Newton's methodological claims at face value and downplay the significance of the metaphysical speculations. It seems difficult. We can't really take them both seriously while maintaining that Newton is being consistent. So people have kind of dealt with this dilemma in a bunch of different ways. And so, for example, Catherine Brading's solution is to kind of say, well, look, the mechanics has implications, that the physics has implications for the metaphysics and vice versa. So Newton isn't really, and so we can kind of make sense of some of the metaphysical claims just as following from the physical claims. She says, quote, various metaphysical aspects of matter theory, such as whether bodies have actual parts, become entangled with the details of the physics. So this is how she makes sense of this. Howard Stein offered a different kind of solution, where he said that Newton had a remarkable capacity for multiple vision. And so the idea here was that Newton kind of was working with both the physics and the metaphysics kind of in sight at the same time, although the two were kind of at different levels of the inquiry and didn't really come together. And so he says that Newton had a disciplined ability to entertain conceptions at more than one level. But the problem with these kinds of solutions, and I'm poking particularly at Howard Stein's solution here, but I think the same thing can be said for a lot of other kinds of solutions to this problem, that the solution tells us nothing about the connections between these different levels. And I don't think it's a very helpful way of seeing what Newton is doing. So I want to offer a different solution to this, which is that we should examine Newton's metaphysics in practice and see what role it plays in his work. And that might help us to understand these methodological claims about hypotheses better. Taking my inspiration here from a kind of fairly recent trend, I guess, in the philosophy of science called philosophy of science in practice. So traditionally, philosophers of science focused on the content, discovery, and justification of knowledge. And similarly, Newton's commentators have focused on the content, validation, and consistency of Newton's metaphysics. In other words, we treat Newton's metaphysics as part of the content of his scientific theories. But the new practice, the new philosophy of science in practice movement, is concerned more with science in the making. They recognize that that there are many other things that are of philosophical significance within scientific practice, and so they're interested in the daily practice. What is it that scientists actually do on a daily basis? They're interested in the processes of inquiry, not just the outcomes of those inquiries or the justification of those outcomes. They're interested in the institutional settings in which science is practiced. They're interested in the social dynamics among investigators and the world beyond the immediate context of inquiry, and so on. And the thought is that each of these features of scientific practice has a role to play in shaping the outcome of that inquiry. There is scope for approaching the history of science in this way. Of course, it is difficult to, philosophers of science in practice, if they're wanting to find out about present day scientific practice, can go into a lab, or they can interview scientists, and they can, actually observe what scientists are doing and conduct ethnographies and all this sort of stuff. Of course, we can't do that when we're thinking about scientists like Isaac Newton, but we can go into the archives and we can have a look at other documents that kind of give us that contain traces of evidence about things like the daily practice and processes of inquiry and institutional settings and things like that. And so I propose that we should focus not just on the content of Newton's metaphysics, but how it's discussed and developed and what roles it plays in Newton's work. And I think that this approach will yield two important insights. At least that's what I'm going to argue today. First, when we look at Newton's metaphysics in practice, we find that his metaphysics is not part of the content of his scientific theories. Rather, it provides an instrument for investigating natural phenomena, and so it scaffolds the inquiry. We should think about it as one of the tools that Newton has at his disposal to increase his reach into the phenomena that he's investigating. The second thing that we find is that the fundamental distinction in Newton's natural philosophical work isn't the distinction between physics and metaphysics, when we understand these two terms as kind of different levels of explanation about the world. It rather is a distinction between theories and hypotheses, and these should be understood as propositions that play complementary roles in scientific inquiry. Okay, so how am I going to do this? First, I'm going to give you my account of the role of hypotheses in Newton's work in a very kind of broad sense. Then I'm going to look at a case study in quite a lot of detail. I'm going to look at the role of Newton's development of the concept of a corpuscle. And then I'm going to give you some lessons from that case. Okay, so let's start with the role of hypotheses. To understand this, I'll start with Newton's theory of light, actually, because this is kind of a way of illustrating what the distinction is. So in Newton's first optical paper, he announced that he had discovered a new property of light, refrangibility. So refrangibility, it's a made-up word. Newton made it up. It means it refers to the disposition of light to refract. So if you take a prism and you take a small beam of white light, and put it through that prism, project it, you find that light separates into its different degrees or dispositions to refract. So it's different refrangibilities. So this is what this property is. Each part of the light has its own has a different disposition to refract. He also then mapped refrangibility to color, and he said that there's a one-to-one correspondence between refrangibility and spectral color. And so refrangibility and color became two properties of light. Okay, so in his first paper, and actually he does the same thing pretty much in book 1 of the optics, he gives us this kind of argument where he starts with the premise that white light is composed of rays of every refrangibility. He then defends a second premise that there's a one-to-one correspondence between refrangibility and spectral color. And then together these give him his conclusion that white light is composed of rays of every spectral color. Okay, having established that white light is a heterogeneous mixture of rays that have different properties, he then draws an epistemic distinction. He gives us First, he claims, like I've said, that white light is a heterogeneous mixture of rays. And he says that this is something that is certain. He says it's not a hypothesis. So he says, for what I shall tell concerning colors is not a hypothesis, but most rigid consequence, not conjectured by barely inferring 'tis thus because not otherwise, or because it satisfies all phenomena, but evinced by the mediation of experiments, concluding directly and without any suspicion of doubt. Near the end of that paper, he also makes another claim. He tells us that white light is a substance, as opposed to a property or a vibration or a pressure in the ether or something like that, or a wave. It's a substance. It's probably made up of corpuscles. But more or less, as soon as he makes this claim, he says, but I'm not going to go any further down this route. I shall not mingle conjectures with certainties. And so the subtext here is that the claim that light is a substance is a conjecture. It's speculation. Okay, and so now we have these two terms. We've got, on the one hand, the claims like this one, that light is a substance. These are hypotheses for Newton. And claims like this one, that white light is a heterogeneous mixture of rays, is a theory. So for Newton, theories are things that are demonstrated via observation and experiment, whereas hypotheses are things that are acquired via speculation. Theories are certain. They are things that have been deduced from experiment, and so we can be certain about them. Hypotheses are not certain. At best, hypotheses are highly probable, but actually it turns out, and as we'll see, Newton, the truth or otherwise of hypotheses is not even at issue. That's not even what they're being introduced for. They're not truth tracking at all, or at least that's not even part of what they're about. And finally, theories are things that generally concern the observable, measurable properties of a phenomenon, whereas hypotheses often concern the underlying nature of the phenomenon. So they're metaphysical. Okay, and Newton kind of distances himself from hypotheses a lot of the time. He says, look, the goal of his inquiries are to establish theories. He says to examine how colors may be thus explained hypothetically is beside my purpose. I never intended to show wherein consists the nature and difference of colors, but only to show that de facto they are original and immutable qualities of the rays which exhibit them. Okay, so this is how I think theories and hypotheses interact. So I'll explain what I think the sort of trajectory is in Newton's methodology. So Newton starts from experiment. He's a, good experimental philosopher most of the time. And he says, look, if we've got a really good experiment, that experiment should give us certainty. We should be able to be certain about, we should be compelled to assent to a proposition if the experiment from which we're deducing that proposition is good enough. Those propositions that we have certainty about because they're deduced from experiment, those are theories. And of course, then we've got hypotheses, and hypotheses interact in some sense. They provide a kind of supporting role in that trajectory from experiment to certain theory. And I'll explain that in a bit more detail now. So first, Newton tells us that hypotheses aren't allowed to constrain our theorizing. And secondly, they're not allowed to influence our epistemic attitude towards theories. They're supposed to purely support the inquiry. So as Newton points out here, he says, should anyone conjecture from the possibility of a hypothesis to the truth of things, I cannot see how they would be able to determine certainty in any science, since numerous other hypotheses always can be invented, which shall seem to overcome new difficulties. And for this reason, I place aside improper arguments from the contemplation of hypotheses. So the idea here is that for any given theory, for any given kind of account of the properties of something, of the properties of light, for example, there's always going to be lots of different hypotheses you can come up with that kind of give that account some sort of underlying metaphysics. And so there's no reason to think that any one particular hypothesis is going to be the true one or the right one. They're going to be underdetermined. And so he says, so that we need to avoid contemplating hypotheses for this kind of reason. He says something, so that first quote came from a letter that Newton wrote to Hooke in 1672, so when he's still working out his new theory of light and colors. But in 1713, when Newton was writing, was preparing the second edition of the Principia for print, he kind of echoes this kind of sentiment. He writes to Roger Coates, who was the editor of the second edition of the Principia. One may suppose that bodies may, by an unknown power, be perpetually accelerated, and so reject the first law of motion. One may suppose that God can create a penetrable body, and so reject the impenetrability of matter. But to admit of such hypotheses in opposition to rational propositions founded upon phenomena by induction is to destroy all arguments taken from phenomena by induction and all principles founded upon such arguments. And therefore, as I regard not hypotheses in explaining the phenomena of nature, so I regard them not in opposition to arguments founded upon phenomena by induction or to the principles settled upon such arguments. In arguing for any principle or proposition from phenomena by induction, hypotheses are not to be considered. The argument holds good until some phenomenon can be produced against it. Okay, so the point of showing you these two different quotes is to show that this is really an enduring feature of Newton's method or methodology. Okay, so what are hypotheses to be used for then, if they're not to be used in guiding us in our acceptance of theories? Well, Newton says, again, so this passage comes from a letter that Newton wrote a couple of years after he first defended his theory of light and colors, where he wrote a paper where he kind of developed his hypothesis. He says, I have observed the heads of some great virtuosos to run much upon hypotheses, as if my discourses wanted a hypothesis to explain them by, and found that some, when I could not make them take my meaning when I spake of the nature of light and colors abstractedly, have readily apprehended it when I illustrated my discourse by hypothesis. Okay, so here he's telling us that hypotheses are allowed to be used to kind of explicate or illustrate theories. Sometimes he kind of thinks that sometimes, if you're sort of contemplating a really abstract theory, it's going to be quite difficult to really kind of grasp how the theory works and what it is. And so he said, well, look, sometimes you might want to kind of use a hypothesis to almost like an analogy or something to kind of give a sense of how it is that the mechanics is going to work. So if I'm worrying about whether it really makes sense to sort of think of white light as being a heterogeneous mixture of rays of different colors, Newton says, well, look, imagine that those bits of light are kind of, really, really small particles, like particles of sand or something. And now imagine how you could divide out sand into sort of different categories, different colors, and then you could mix them back together again and stuff like that. And so that's supposed to kind of help you to understand what the theory is about, but you're not supposed to kind of really believe the hypothesis or think about it as part of the content of the theory. And of course, the point here is that, as he says, you can always come up with any number of hypotheses that will do that work for you. I mean, some are going to do the work better than others. Some are going to be completely inappropriate. But as he puts it, I knew that the properties which I declared of light were in some measure capable of being explicated, not only by that, but by many other mechanical hypotheses. Okay, here's another use for them. And again, this is a letter that Newton wrote to parties in 1672 to defend his theory again. And he says, look, hypotheses ought to be brought forward only to explicate the properties of things and not to be unlawfully assumed. So he uses the term usuparity here in determining them, except insofar as they may furnish experiments. Okay, so here the idea is that hypotheses are allowed to be employed to help reveal new phenomena. They can be used to suggest new experiments, things like that. They can kind of scaffold the experimental process. Importantly, hypotheses are only temporary. If you introduce a hypothesis to illustrate a theory, you need to make it clear that that hypothesis is not to be considered part of the theory. It's just being used to kind of help people to understand the theory, to make it intelligible. If you introduce a hypothesis to help you suggest an experiment, the goal there is for that experiment then to produce new phenomena, new measurements that will then stand on their own without that hypothesis being required to kind of be assumed to understand those experiments. And so the final product, the theory, should be cleansed of all hypotheses. Okay. Luckily for us, though, Newton wasn't always entirely successful at cleansing his final theories from hypotheses, which leaves us with some very helpful traces to be able to understand what's going on a bit better. And so now I'm going to look at how it is that Newton used hypotheses, develop the hypothesis of a corpuscle in order to kind of develop his theory of light. Okay. In his earliest publications on optics, or in his earliest publication on optics, as we saw, Newton argued that light is a substance. So he defended this in the following way. So the idea is that he noted that when you look at an object like a chair or something like that, what you're seeing is light that is reflecting from that chair into your eyes. And so the blueness of a chair, for example, is not blueness that's really in the object itself. The blueness is in the light that's being reflected off that chair. Okay, so he made this claim. I'll break it down into sections so we can kind of get the idea of it. Okay, so first he weighs into a really important metaphysical discussion that is going on at the time about whether there are colors in the dark. And he says, in light of what he has discovered about the composition of white light, that is the heterogeneity of white light, he says these things being so, it can no longer be disputed whether there be colors in the dark or whether they be qualities of the objects we see, nor know perhaps whether light be a body. Okay, so he's claiming here that light is a body, it's a substance. He's working with a very thin notion of substance here. Substance for Newton in this passage is something that does not depend on other things for its existence and is the bearer of or instantiates qualities. So it's just substance is kind of, in some sense, the thing that individuates qualities, or it's the thing on which qualities hang in order to make them properties of something or qualities of something. Okay, then he says, for since colors are the qualities of light, having its rays for their entire and immediate subject, how can we think those rays qualities also, unless one quality may be the subject of and sustain another, which is in effect to call it substance? And so he's telling us that since color is a quality or property of light, we should consider light to be a substance. That is, light should be a thing that has qualities. Then he goes on, we should not know bodies for substances were it not for their sensible qualities. And the principle of those being now found due to something else, we have as good reason to believe that to be a substance also. So the point here he's making here is that since we recognize substance by its sensible qualities, such as color, so we recognize a chair as a substance because it's got qualities to it, it's got hardness, it's got form, it's got color, and so on. And so we recognize it as a substance because of its sensible qualities. And so we should recognize that light is a substance too, because it too has sensible qualities. Okay, so the long and the short of it here is that light performs the subject role the substance role with respect to color qualities. This is what Newton is telling us. He does not use this idea of light being a substance to attribute any properties to light beyond the ones that he has empirically established, namely refrangibility and color. Okay, so we should think of this as a concept differentiation rather than Newton doing any real ontological work here. The substance attribute distinction was one that was widely accepted at the time, and Newton is essentially co-opting that distinction to show that the traditional classification of light as a quality doesn't make conceptual sense, given the empirical evidence that he has to hand. So whatever his reasons for introducing the substance discussion at this point, it's not to kind of improve the explanation of colored bodies, which he already regards as kind of entire and adequate. And so that's what he says here. He says that this is the entire and adequate cause of their colors, the colors of bodies, as manifest, because they have no power to change or alter the color of any sort of rays incident apart, but put on all colors indifferently with which they are enlightened. Okay, so we get a bit more metaphysical speculation in Newton's later paper, his 1675 paper. Okay, so in his 1675 paper and also in book 2 of the Optics, Newton wants to develop a theory of colored bodies. What he wants to do is to be able to explain how, in virtue of what it is that, say, the blue chair reflects all and only the blue light. And he kind of, I mean, he first, in some of his earlier work, he sort of tries to look at whether just refrangibility can do this work for him, whether he can explain it that way. And he finds that it doesn't really work. So then he starts looking around for other optical phenomena that might kind of offer a clue. And he refers to these as observations on thin plates. It's now known as Newton's rings. It's an interference phenomenon. So it's the phenomenon where you get a bunch of kind of concentric circles of light reflecting off a surface. You often you might see it in kind of puddles where, when the sun's shining off a puddle on the ground or off a pool of water in the right way, you'll see, some concentric rings of light. You find it also in sort of badly made double pane windows and things like that, when the two surfaces of the window aren't quite meeting properly. And again, when the sun shines on it at a certain angle, you'll get these kind of concentric rings of light. And so Newton's insight is that if we can explain interference phenomena, then he would be able to explain how bodies reflect particular colors. So his basic insight that light has inherent properties of color and refrangibility wasn't enough to do this, so he developed a hypothesis. Okay, here's his hypothesis. His hypothesis kind of has 3 parts to it. He says there's an ethereal medium, and then there's light, which is separate, and the two of these things interact. So ether is a thing that fills empty spaces, including the pores of solid substances. It vibrates, carrying sounds, scents, and light in it. And the vibrations differ in size, and this can kind of give rise to different kinds of sensations. Light is a substance propagated from lucid bodies, and it travels through ether. And the rays are physically heterogeneous, differing in size, shape, and velocity. And light warms the ether presses on the light, and this is how the two of them interact. And the separation of the two things is really important for Newton. He says, I suppose light is neither this ether nor its vibrating motion, but something of a different kind propagated from lucid bodies. Okay, so then Newton carried out a bunch of experiments in order to establish a new phenomenon, periodicity. So he started with this phenomenon was pretty it was kind of pretty messy, right? He started with kind of his first experiments. He just kind of grabbed 2 prisms together and kind of mashed them together, tried to kind of press them together as tight as he could so that the two surfaces would meet, and he sort of tried to study the phenomena that way, but he wasn't getting a very regular phenomenon. And so eventually he had the kind of insight that what he needed was if he could take a perfectly flat piece of glass, and then he could take a lens with a known curvature to it that was kind of flat on one side and a perfect spherical curve on the other side, and he could place them together. And that allowed him to generate, really, really regular interlocking, really, really regular concentric circles of light. And this allowed him to establish this new phenomenon, periodicity. Okay, so he did all these investigations, he did all these measurements, carefully, painstakingly measured and drew the different circles and so on. And eventually what he realized was that there was that the diameter of the circles was proportional to the kind of gap between the two layers of glass, what he called the thin plate. Sorry, I'm very distracted. The people next door seem to be drilling something. Anyway, hopefully you guys can't hear it. Okay, yeah, so he realized that there was this relationship between these two things, the diameter of the ring and the distance between the two plates. Okay, and that led him to kind of explore this kind of further. He realized that you get different circles if you look at the sort of setup from the top versus the bottom, and you get different colors, right? So these rings were often, if you looked at them carefully enough, you'd find that they were kind of repeating colors. And so what you find, what this figure here tells us is that when you can see, say, a red circle on the top layer, you can't see a red circle on the bottom layer, and so on. And so they were sort of different patterns. Okay, he also used he would kind of isolate just red light, and he examined what the rings look like when you're just looking at with one color through this setup. And so he did this with kind of different colors, and what he found was he drew this kind of figure, where what we find here is that light, when you shine light of a certain color onto the thin plate, it either reflects or it is transmitted through the two layers, but never both at the same time. And this is what gives you these very, very regular periodic rings of light. And this is what he concluded. He said, "From thence the origin of these rings is manifest, namely that the air between the glasses, according to its various thickness, is disposed in some places to reflect and in others to transmit the light of any one color, and in the same place to reflect that of one color where it transmits that of another." Okay, so now he had established his periodicity. Now he wanted to explain why light refracts and reflects very, very regularly in this way. Okay, so this is when he turned to his hypothesis, and he drew an analogy really here, and he said, well, look, imagine that you're throwing stones into a pool of water. Well, they would create ripples, right? They create these concentric ripples of like vibrations of water. Okay, and that looks a bit like a familiar phenomenon when you're thinking about these rings of light. And so he's now thinking about light causing a vibration in the ether, and he says, well, what would happen to the light if it's traveling with that vibration? Right, and he called this kind of vibration a pulse. Okay, and then he started thinking about what would happen with the light, and he said, well, it could be like the light kind of gets caught in a wave. So if any of you have ever tried, I don't know, surfing, or probably even just spending some time in the ocean, you would know that, if you swim out a little bit from the shore, if you get caught in a wave, if you manage to catch a wave, it'll sort of pull you back to the shore with it. If you don't catch a wave, you might get kind of pushed further out to sea, or at least you don't get pulled in. And so he started thinking about light like this. If light gets kind of caught in the vibration or in caught with the pulse, then it's going to get kind of pulled through to the next, to the next surface. And if the light kind of finds itself not caught with the wave, but kind of working against the wave, it's going to kind of be reflected back out, was the thought. Okay. And so then this allowed him to say, well, like the vibration is expanding and contracting, just like a wave does. This is why sometimes the light can get kind of carried through with that vibration, and sometimes it gets stopped. And so he decided that this pulse was the distance or period between expansion and contraction of a wave. And he said one pulse is going to lead to the light being reflected. 2 pulses is going to lead to the light being transmitted. 3 pulses is going to give you reflection, and so on. And this is where you get this kind of extremely regular periodic reflection and refraction going on. And importantly, each color excites pulses of a different length in the ether. There's just at the very least one problem with this. Really, you can see there's a really kind of nice account building here, but how do you detect a pulse? Well, Newton thought that a pulse was indicated by the regularity of the phenomenon. So he'd already noted that there's a relationship between the diameter of the circles and the thickness at that point in the thin plate. Another thing that Newton had noticed was that at the very center of the setup, when the 2 plates are perfectly touching, and so there's no space between them, light is transmitted. So light is transmitted when the 2 surfaces touch, and then it's reflected, and periodically after that. And so Newton was able to figure out that the smallest ring indicates the smallest gap required for reflection. And so, so that small gap is the measure of one pulse. And Newton was able to figure out what this how thick this was, like what this distance is, what one pulse is for any given color, because he could calculate it based on the known sphericity of his lens, because he ground the lens himself and knew what the thickness would be. So a pulse became a unit of measurement. So reflection occurs, for example, when the distance equals 1, 3, 5, 7, etc. pulses, and transmission occurs when the distance equals 2, 4, 6, 8, etc. pulses. So what we've seen here is that Newton took a vague metaphysical concept, neither observable nor measurable directly, and attaching it to an empirical effect, clearly defined it. In other words, he operationalized it. Okay, so now I'll show you how this account develops from its initial conception in 1665 through to its publication in the Optics in 1704. Okay, so in 1665, Newton already had this idea that that there was a pulse, that the vibrating medium had a pulse to it. So we find this kind of language here. In 1675, when Newton is writing about his hypothesis to the Royal Society, we see sort of similar language. At this point, he's thinking about the condensation and expansion of waves, and so on. So we see this kind of, we see that he's using this metaphysics to explain his rings, to explain the rings. In 1690, by 1619, Newton had a full draft of the optics that he in fact sent to the printers, or sent to the publishers. And in that, he tells us this. He says the vibrations excited by the more refrangible rays are shorter than those excited by the less refrangible ones. So again, we've got this, vibrations being excited and so on. And we've got this, the length of the vibrations and all this kind of language. So we've still got this kind of heavily hypothesis-laden language. Newton withdrew that version of the optics from publication. And there was a gap of 14 years where he rewrote book 2, in which he develops this account. The rest of the book is was published pretty much the same, but book 2 was like a lot of it was changed. And so finally, in 1704, when it was published, here's the account that we got from Newton. This is Proposition 12 from Book 2, Part 3, where he finally gets to the point. He says, every ray of light in its passage through any refracting surface is put into a certain transient constitutional state, which is the progress of the ray, which in the progress of the ray returns at equal intervals and disposes the ray at every return to be easily transmitted through the next refracting surface, and between the returns to be easily reflected by it. So that makes no sense. It probably doesn't make any sense to you guys. It didn't to the readers of the optics. This kind of seems a bit like nonsense, but this is how Newton had kind of eventually developed a theory which wasn't so reliant on a hypothesis. It doesn't really make sense. But he kind of recognized that it wasn't going to make sense, and so he included this explanation right after he explains that, right after he introduces that proposition. Okay, he says, well, look, this kind of disposition, I'm not interested in what the metaphysics of this disposition is, what is its nature or whatever. I'm not interested in that. However, those who are averse from assenting to these kinds of theories without, may for the present suppose. And so then he gives us a hypothesis. He says, as stones falling upon water, put the water into an undulating motion, bodies by percussion excite vibrations in the air, and so on. So he gives us, again, these are kind of familiar, these are kind of analogies to the idea of light creating vibration in an ether. Okay, and then he says, so the rays of light excite vibrations, they agitate the solid parts of the refracting or reflecting body. Okay, and then he goes on, the vibrations thus excited are propagated in the air for causing sound, and they move faster than the rays as to overtake them. Okay, and so he's kind of like the rays will kind of, I'll go back to that previous point, that the vibrations are propagated through the air or through the ether. And the light rays, if the light is traveling, the vibrations will move faster than the light and overtake them. And then he says, when any ray is in that part of the vibration which conspires with its motion, it easily breaks through a refracting surface. But when it is contrary to the part of the vibration which impedes its motion, it is easily reflected. And by consequence, that every ray is successively disposed to be easily reflected or easily transmitted by every vibration which overtakes it. Okay, so that account is familiar to us because I've just told you about it before. He's basically given us exactly the account that as a hypothesis that he had worked really hard to kind of extract from the theoretical content of the theory, of his theory of light and colors. As soon as he finishes that explanation, he says this. He says, but whether this hypothesis be true or false, I do not here consider. I content myself with the bare discovery that the rays of light are, by some cause or other, alternately disposed to be reflected or refracted for many vicissitudes. And then, to really signal that this is the end of the discussion of the hypothesis, he introduces a new definition. He says the returns of the disposition of any ray to be reflected, I will call its fits of easy reflection, and those of its disposition to be transmitted, its fits of easy transmission, and the space it passes between every return and the next return, the interval of its fits. And the rest of this book of the optics is focused on the interval of fits and using that as a way of predicting what color will appear at different points. And so, so Newton used, so the long and the short of this is that Newton used the hypothesis of ethereal vibrations to posit a physical cause for the observed pattern of colored rings. He posited an ethereal pulse. He displayed no epistemic commitment to the hypothesis itself, and instead he operationalized the concept. This gave him a new unit of measurement, an interval of fits, and a way of formalizing and abstracting the explanation of the thin plates. So he developed his theory of fits. He then used the new unit, the interval of fits, to explain his earlier observations. He developed, I won't go into the details of what that graph shows, but he also used his interval of fits to unify several optical phenomena. So he was able to draw together the kind of colors that you see in a sphere, in a kind of glass sphere. So kind of what he termed a thick plate, He talked about the kind of rainbow colors that you see in raindrops and even in rainbows, and also the kind of the rings of colored light that you see if you stare at the sun too long and things like that. And he argued that the reason why the surfaces of all thick, transparent bodies reflect part of the light incident on them and refract the rest is that some rays in their incidence are in fits of easy reflection and others in their fits of easy transmission. So the color of a body depends entirely on the size and density of its corpuscles, is the upshot of this. And he writes that from these propositions, it is easy to collect the intervals of the fits of easy reflection and easy transmission of any sort of rays refracted in any angle onto any medium, and thence to know whether the rays shall be reflected or transmitted at their subsequent incidence upon any other pellucid medium. This ended up being a quite predictively strong theory. And it ended up being used to make predictions about the size and shape of other bodies and things like that. It ended up being quite good, even though by today's standards, we just don't think it's right at all. Okay, I'm going to move on to, I think I've given you, I do have quite a lot more to tell you about this hypothesis, but I think I should, given the time, I'm just going to move down to and just give you move to my conclusions. I think that's probably the best thing to do. Okay, so my lessons from this case. It's tempting to think that Newton's metaphysics is somewhat fundamental to his physics. That's what people think. And Newton's commentators complain that his metaphysics is inconsistent and incomplete, and it's at odds with his explicit methodology. It's inconsistent in that, you know, in some places, Newton seems to be talking about the fact that there's an ethereal medium that permeates empty spaces. But then in other places, he tells us that, but then in other places, but then in other places, he's talking about how there is kind of empty space. So it's not surprising, though, once we attend to the role of metaphysics in Newton's natural philosophy, that there are these kinds of inconsistencies and incompletenesses. So in our case study, Newton's metaphysical speculation was based on the capacity of certain kinds of entities and processes to support properties he had experimentally established. His hypotheses were developed through a complex process of reasoning, from observed effects to underlying causes, drawing analogies with other known causes and effects, and so on. But unless the hypothesis was being used as a possibility of proof or a scaffold for his experimental or empirical inquiry, he wasn't interested in developing it further. This means that often his metaphysics was incomplete, or his hypotheses were incomplete. They were also extremely local. They only ever really applied to the case that he was working on at that point. Okay, so remember I said there were going to be two important insights from looking at Newton's metaphysics in practice. And so I said that his metaphysics wasn't the part of the content of the theories. And also I said that we would see that the fundamental distinction in Newton's work is actually a distinction between theories and hypotheses that are kind of working together, playing complementary roles in scientific inquiry. So what we find, the upshot of this is that Newton's metaphysical speculation is not directly concerned with what the world is actually like. Rather, it allows him to design empirical approaches which themselves reveal the world's structure and nature. Okay, you might worry that I haven't really talked about Newton's metaphysics. Rather, I've focused on a case of empirically focused speculation, let's call it. It's true that I'm working with a kind of anachronistic notion of metaphysics. So in the early modern period, metaphysics connotes Aristotelian notions of first causes. So there's a typo there. And that's not really what I'm working on. But I think there is a precedent for thinking about this stuff as metaphysics for Newton. Anachronistically, we might understand metaphysics as the discussion of general features of the constitution of the world and the principles of inquiry into the nature of reality. And I think that Newton's speculations on the nature of light fit this understanding of metaphysics. Also, I think there's a precedent among Newton's commentators for using the term metaphysics to refer to things like Newton's speculations on the nature of light. Okay, I started with a dilemma. And I think my approach to to dealing with Newton's metaphysics in practice could yield two kinds of claims. There's a kind of a weak version, there's a weak claim I could make here, and there's a stronger claim. So the weak claim is that one way of resolving the dilemma is to focus on the methodological role played by metaphysical speculations in Newton's scientific practice. The stronger claim is that once we focus on the methodological role played by metaphysical speculations in Newton's scientific practice, the dilemma resolves. Sorry, the dilemma dissolves. I haven't yet decided which one of these two things I want to argue for. Note that this is not an argument against taking Newton's metaphysics seriously. Rather, it's an argument for how to approach Newton's metaphysics. So I think it's a mistake to treat Newton's corpuscular hypothesis as part of the content of his theory of light. And I think by the same token, it's a mistake to treat ether as part of Newton's theory of universal gravitation. And it might turn out to be a mistake to treat absolute space as part of Newton's mechanics. And that is the end. Thank you.
Well, thank you so much, Kirsten, for this wonderful talk. I really enjoy it. And now we have some time for the discussion. So please raise your hand. I have Robert and then Dubian. Yes, please, Robert. Let me see if we have, yes, you can open your mic. Is that right, Yvette? Let's see, well, maybe Dubian then, because
Okay. Thank you very much, Professor Kristen, for your very, very interesting talk. I have two questions. One about your stimulating thesis about Newton's metaphysics, and the other one is more methodological about your integration of HPS and philosophy of science in practice in order to do historical work.
Yeah, great.
So that my first question is, you mainly focus on the optics, and this is an analytic work. I mean, it applies the methods of analysis rather than synthesis, unlike Newton's Principia, right? And my question is whether do you consider that Newton's metaphysical hypothesis play the same role you are attributing to them, namely the role of inquiry scaffolding in synthesis, not just in the process of analysis, of discovering general or establishing general empirical principles from particular observations and phenomena. That
Yeah.
does make sense?
Yeah, that does. Yeah, that does. Okay, I haven't worked out the details of this in relation to some of the things that go on in the Principia in the same kind of, to the same level that I have with the optics. But my sense is that we find hypotheses playing a range of different kinds of supportive roles in a lot of Newton's reasoning. So in this case, so in this case, I've shown you a case where the hypotheses, so I think the hypotheses are playing, it's not just a discovery role right here. It's not just that these hypotheses are kind of being used to kind of suggest new experiments or to kind of suggest new ways of extracting evidence from empirical situations. Hypotheses are also, I think in this case, the hypothesis is also in some sense scaffolding the development of the theory. As for whether the hypothesis is still in use on the other side of that, because there is some, I think the second step that I kind of illustrated very briefly at the end of that case study was that it does play a synthetic role too for Newton in book 2 of the Optics, where he where he uses his theory of fits to then as a predictor for other phenomena and things like that. And yeah, I mean, he takes himself to be just using the theory at that point, rather than using hypotheses. So sorry, this is very much me thinking out loud about how this works. So I think maybe what I've given you here is, yeah, a case where hypotheses are being used in the kind of analytic step or in the analysis step, and we might not see it so much in the synthesis step. But I'm not sure that I want that to be my final answer on this. I'm just trying to think. There are places in the Principia where Newton introduces a hypothesis during a synthesis phase, I think. And these things provide some sort of temporary scaffolding that allow him to kind of push through to the next calculation and things like that. So yeah, I think my answer ultimately is I'm not sure. I need to work through the details. Sorry.
Thank you. It's clearer for me. And the second question is about using the approach of the philosophy of science in practice to do historical research. It's very interesting for me because I find a common ground between today's history of science and the philosophy of focus on practice, which is to study science in the making of science, right? And it involves
Yeah.
paying attention to social context, material culture, epistemic activities, and so on and so forth. And my question is, what do you think about the possible productive conversation with mainstream history of science, which is a bit separated from conservative HPS?
Oh,
Because
that's a
if we adopt the philosophy of science in practice to do HPS, but the philosophy of science in practice investigates science in terms of the making of science, but professional historians of science are also studying science in such terms. So why not to include professional history of science for doing HPS work? What do you think?
I mean, I do think that often when we philosophers of science, let's say, who with a historical bent come along and say, hey, we should be thinking about the institutional context in which science is produced. We're basically when we try to tell historians of science that, we're basically trying to teach grandma to suck eggs. I don't know if actually that's an expression beyond Australia. We're telling them something that they've been doing for decades, and they're like, yeah, no shit, we should be, of course. Why haven't you guys been doing this for ages? And so I think there is a sense in which the philosophers of science are the ones that really need that lesson, not so much the historians of science. I mean, I think what we bring to the table when we HPS people or philosophers of science kind of start doing this work is that we're bringing in, like, philosophers of science always bring in a more kind of normative attitude towards looking at the development of science, and so we bring different kinds of questions to our historical studies, and so I think there's kind of room for all of us to be doing this kind of work, and I think we're doing it with a different lens, I think, is probably the way to think about it. I guess I'm kind of I think I kind of take a fairly ecumenical view of this. I'm some sort of pluralist about this. I think that there's probably not one right way to be doing this kind of history or like using the history. I think there are a bunch of wrong ways to be doing it. We can, we certainly should avoid being appropriationists if at all possible. We should avoid trying to use, history as toy cases and playing fast and loose with the historical details. And I think there's a whole lot of things that we shouldn't be doing. But I think also, I think there's a lot of different ways of bringing insights like the material turn and the practice turn and so on into our work as HPS people in ways that, yeah, that I think are kind of helpful for philosophers to be knowing about. Yeah.
Thank you.
Thank you. Robert?
Hi, I'd like to apologize for not being able to. I was trying to get the video on and didn't realize that I didn't have the audio on.
No
But
problem.
thanks for calling on me. This is a very interesting topic. I have a question and then I think a comment. And the question, to preface it, if we look at the various editions of the Principia, I fail to understand why Newton uses the term hypothesis in the places that he does. So what we find in the second and third edition at the beginning of book 3 are the rules of reasoning in experimental philosophy, and then various phenomena, which are really Kepler laws as applied to moons of planets and the planets themselves. But in the first edition, all of these are listed as hypotheses, along with the hypothesis that the center of the world is at rest. And in later editions, that survives as a hypothesis, but it's not really a bit of speculative metaphysics. I mean, what it's used then in order to derive that it's the center of mass of the solar system that is at rest, not the sun or the earth as everybody had previously supposed. And furthermore, he says this is a hypothesis that everyone accepts. Okay, so how do we make sense out of this change in usage of hypothesis, or different uses of the term hypothesis in an official capacity? And then the part that I would like to argue on, that absolute space does not play a role or is not part of the theory of mechanics. To the extent that Newton wants to track true versus merely apparent motion, I mean, the conclusions that he arrives at in book 3 concern true motions. So if you think that absolute space is needed, as Newton did, in order to underwrite the notion of true motion, then it's a part of the theory.
Yeah, those are really good questions. Okay, so I'll start with the changing of the labeling, like, you know, the labeling of hypotheses in the Principia. And you're right that, I mean, the key thing here, I think, is that the first edition of the Principia, opening as it does with a list of hypotheses, is really an outlier, right? You know, that's the only place in Newton's published work where you ever see a list of hypotheses like that. I think that at that point, I mean, because already, so, you know, the first edition, I'm just saying this for maybe people that aren't familiar quite with all the dates on this. The first edition of the Principia is published in, what, 1686. And the optical work that I was talking about when Newton is talking about how we shouldn't use hypotheses, a lot of that comes from 1672. So that's, you know, so Newton already has these views about hypotheses when he's doing optics, well before he publishes the Principia. And yet in the Principia, there's all these hypotheses. So I think that, and then by 1713, when Newton publishes the second edition of the Principia, he's relabeled all of those propositions as other things, except with a couple of exceptions. And so he turns all of the claims he's made about all of his empirical claims about the patterns of patterns of motion of the celestial bodies, he now calls them phenomena. All of his claims about that are kind of rules of inference. He's now called them rules of philosophizing, and so on. And then we get, like you said, a couple of outliers. There's the that make these other kinds of claims. I think that what has happened there is that when Newton initially wrote the Principia, he didn't conceive of it as being kind of methodologically on a par with either his early optical work or with the kind of experimental philosophy that was going on at the Royal Society. And so because he doesn't use any of the kind of rhetoric there about anti-hypotheses, that other people at the Royal Society are doing. But I think that by the time he was preparing the second edition for publication, I think he had kind of realized that actually he'd be better off making this look more like a work of experimental philosophy. It could have been that Roger Coates had something to do with this, helping him to see that actually, you could bring these two works kind of into, make them much more similar, or, make them match much more methodologically by just kind of thinking more carefully about how the term hypothesis was being used or something like that. So that's why I think that maybe that change of labeling happened. And so I think that the first edition is kind of a weird outlier. But you're right that there are also these hypotheses in, especially in book 3, but there's also at least one in book 2. And again, it's not really a metaphysical hypothesis, like you said. So I gave you kind of a really informal account of what I take to be the difference between a theory and hypothesis for Newton kind of early on in the talk. I sort of played a bit fast and loose with that. What I've done in my own work is to develop a definition that kind of, sorry, I'm blanking on my words. It's been quite loud here. So I've got a definition of hypothesis that's much more kind of broad than this, where I say, well, look, a hypothesis is either something that's kind of metaphysical in content, or speculative in content, or it's, and it kind of plays it's a bunch of different things. So I think the upshot of this for me is that not all hypotheses are metaphysical, but to be a hypothesis is to play a certain kind of role for Newton, and it's a role that's kind of a temporary scaffold in the account or in the inference or something like that. And that's definitely what we find in book 3 of the Principia, is that when Newton makes his, introduces hypothesis 1 to make the assumption that the center of the system is at rest. Is that what it is? Yeah. He's making an assumption. It's kind of a temporary scaffold. He's very clear that it doesn't really matter whether we're assuming that the center of the system of the world is at rest or whether it's moving. But it's going to be helpful for the calculations if we assume one or the other. Assuming it's at rest kind of makes the calculations easier, and it doesn't matter because we still get kind of, we get good enough results that way. So I think that that's what he's doing often with his I think that's the role that hypotheses are playing in the Principia for him. So yeah, they're not always metaphysical, but they do always play this kind of temporary scaffolding kind of role. As for whether or not absolute space is part of the content of the theory, again, I haven't yet kind of done the work to really think carefully about this, but I think that that in book 3, Newton is concerned with real motion as opposed to, or true motion as opposed to absolute motion. And so I kind of think that maybe Emily de Châtelet was right about this, and that maybe all Newton really needed, he needs a fixed reference, but he doesn't need to make the metaphysical assumption about that absolute space exists in order to do what he is trying to do with it. But like I said, I don't think I'm in a position to defend that claim strongly. And I also know that you know a lot more about this than I do. So Yeah, so I'm very interested to hear what you think about that.
Yeah, I don't know what you mean by real motion, unless that's just true motion, and Newton thinks that true motion only makes sense if you have absolute space, if you have true space. Let's see. I tend to doubt what you said about the role of hypothesis one in the later editions, that it simplifies the calculations. And it's interesting in the thing that was never published during his life, the system of the world. When that finally does appear, that hypothesis shows up in a capacity. Of course, you don't have labeling of hypotheses and so on there, but when it's addressed, it's recognized that, according to Corollary 5, it's possible that the center of the mass of the world is in uniform motion, uniform inertial motion. But in the system of the world, it says, but to imagine this is a hypothesis that is, well, in the Latin, it's dura, which literally means hard. In an English translation that followed almost immediately afterwards, it says is not at all to be taken seriously, or is not at all reasonable. So there, it's a question not of making the calculations easier, but of really a picture of the system of the world.
Yeah, okay.
Okay. Well,
I'll have to have more think about this, yeah.
Okay,
okay.
thank you.
Thank you.
Thank you. Maria del Mar.
Thank you. Hi, Kirsten. It's very nice to see you, and thank you so much for the talk. I have a question, and it's, if I understood correctly, hypotheses have a role for Newton in which they are legitimate to, for example, convey scientific meaning, in the sense that we can use, for example, analogies or imagination to make the public understand easier what we're thinking about, while other having a simultaneous role of trying to propose new experiments. But however, we cannot use them to reach our final epistemic commitments about the certainty of how it is working in reality. If that's the case, I wonder if Newton is kind of facing a dead end when trying to face how human nature kind of tries to understand natural phenomena. I'm thinking about Cavendish here, for example, when she talks about natural sense and reason, and it's about imagination playing a crucial role in the constitution of human mind, as well as reason, in the sense that even if we try to kind of purge this speculative hypothesis at the end of our theoretical commitments, in the end, it appears that we cannot try to actually eliminate speculation completely, because trying to assume that if we can observe phenomena completely free from speculation in the way that we are going to interpret them and propose those results, I wonder if that's a little bit naive of Newton, and that maybe the clash that's coming in this apparent dilemma or confusion is to see how this part of the method in which you say, I can rely on these speculative parts, which are not going to be part of my final commitment, can actually lead to a final commitment, which is like pure or separate from those speculative parts of the method. So I was wondering what you thought about that kind of disconnect, and if you think that Newton might be a little bit naive about the actual role of speculation in natural philosophy. Also because I think that it is something that we can also see nowadays in how science is being practiced, as you mentioned about this new branch of science in practice, because sometimes you can see that some scientists are very naive about the role that this kind of imagination analogies and different images, and even from fantasy, can play in the way they observe natural phenomena. So I wanted to ask your opinion about that.
Yeah, I mean, really good question. I think I'm always hesitant to use the word naive when it comes to talking about Newton's methodology, but it's clear that it's clear that it's not always successful for him. And this is why I particularly like this kind of case for Newton. Like when I'm looking at Newton, because I think it is a case where he's tried to separate out the hypothesis, he's tried to kind of follow this methodology that I've extracted from his work. But it's been imperfect. He hasn't been able to extract the hypothesis. You can see evidence of it all over book 2 of the Optics. It's there. The final worked out theory is kind of almost impossible to understand if you don't know what he's actually thinking. But in addition to that, the hypothesis leads him wrong at the end of the day. One of the reasons why who knows what he could have figured out if he'd been working with a different hypothesis, but it's clear that he so one of the mistakes he makes is in thinking that the real action is going on between the two surfaces of the plate, like that it's the air, that it's those two surfaces that are touching the air that are the really key ones where the action is happening, where it turns out that it's actually on the far surface where the real action is sort of supposed to be happening. And so this leads him kind of down the wrong path. Like he's kind of measuring the wrong thing. And so it's not clear whether he could have done better if he had realized that, or if he'd had a different hypothesis. But it is definitely one of, like you say, it's a place where the I use this scaffolding is an analogy for what goes on in architecture or whatever. But the thing is that scaffolding in architecture kind of does constrain you, right? When you're building a new building and you put your kind of scaffolding up, your building can't go wildly beyond what the scaffolding is giving you, right? You can't, and I think it's the same with this kind of scaffolding that Newton is using, his metaphysical scaffolding that he's using to kind of try and understand this, where he can't, it constrains him to look at the phenomena in a certain kind of way and only make certain kinds of observations. So yeah, but I'm not sure if it's naive, because it's also incredibly, like, it was quite an impressive theory that he managed to develop. As for, you also said something really interesting about the role of kind of imagination and its relation to speculation. I'm not sure if I have anything very interesting to say about this yet. I have been doing a bit of work thinking about analogies. And I know, but the only place I can think of where Newton had anything really interesting to say about kind of imagination and fancy is actually in some of his kind of theological work. And I have not sort of gone down that rabbit hole to try and understand that stuff yet, unfortunately.
Great. Thank you so much, Kirsten.
Thank you. And we have time for one last question. Andres?
Yeah, can you hear me?
Yes, I can.
Yes.
Hi, Professor Kirsten. Thank you so much for your talk. My question goes in the same way that Maria's, and I wonder if you may broaden your thesis to understand scientific practice in general. And so if I understand correctly, we might divide metaphysics and hypotheses from theories, being hypotheses like not so epistemically reliable, and theories like more epistemic reliable product, right? And so I'm wondering if this solution may takes us to a dilemma. And so if you admit Newton's metaphysics, then you have understanding of what the phenomenon is. But again, you have taken metaphysics, Newtonian metaphysics. And if you don't, then it seems that you don't have understanding. So it seems a case where if you take only the theory, you may have knowledge, but not understanding. Shall we maybe broaden this to scientific practice in general? I mean, this is a question that maybe is not going in the same way as your presentation. I just want to know your insights about this.
Yeah, I think that when we look more carefully at things like Newton's work, and we start looking at the role of, say, experiment in kind of giving people knowledge of the world and things like that, I think we end up finding that that knowledge is a much kind of broader category of thing. Then we tend to think, okay, knowledge is going to be this thing that's kind of that's going to be propositional, it's going to be first person, it's going to be it can be justified or using sort of traditional proof methods and things like that. There's a sort of certain expectation you have when you go into someone like Newton's work. But then Newton does things like gives us kind of a proof by experiments in book 1 of the Optics, and where the kind of probative force of that proof is in experiencing the experiments. And there is a thing, there is a way in which Newton seems to think that kind of a really good experiment will give you certainty about some sort of proposition that's been deduced from that experiment. And I don't think that kind of certainty can be kind of captured using kind of formal propositional language or formal proofs. I think what's going on, sorry, excuse me, is that he has a kind of a notion of knowledge which is about kind of grasp of the phenomena, and kind of there's a really kind of experiential component to the way that Newton seems to be thinking about knowledge, especially in the Optics. I think there might be a lesson in that for other parts of scientific practice, although as I kind of said in my answer to Dubian, that I suspect that other philosophers of science in practice already have realized this about present day scientific practice. They're working with these kind of fairly fine-grained distinctions between understanding and knowledge, and as you said. So yeah, I think I'm not sure whether that has answered your question, but I think there's a lot of interesting things that we can learn by kind of by bringing these methods of kind of philosophy of science in practice into the historical area and rethinking, and having a closer look at these kind of key scientific figures, or any early modern scientists, or where I think we learn a lot more about the kind of the subtleties of what they take to be knowledge and how they are defending that and things like that. Yeah.
Thank you. Well, thank you very much for your questions, and thank you very much, Kirsten, for this wonderful first paper of our workshop.